Good day to my examiners. My name is Raghavendra Rao Analaki Chandra Rao, matrix number 1920611021. So today I'll be talking about temperature control exhaust fan using Arduino. Okay, exhaust fan is something that reduces surroundings temperature. Okay, I think almost every house we actually have an exhaust fan. Exhaust fan also removes unhealthy air pollutants. Okay, but exhaust fan has one lacking where it doesn't have a temperature sensor to automatically activate whenever it detects a spike in temperature. So therefore, in this project, exhaust fan will be automatically turned on when there is an increase of temperature, specifically when it goes above 35 degrees Celsius, because 35 degrees Celsius is known to be a very warm surroundings. So that's why 35 degrees Celsius has been set where the exhaust fan starts to turn on. Okay, so objectives of this project is to develop a system which is able to notify surroundings temperature. Next is to design the project's prototype using SolidWorks. Next is to develop a heat detecting system that can measure the temperature of the surroundings. Okay, for the problem statement, firstly, there is actually wastage of electricity due to continuous run of exhaust fan. For example, when you're at your household and then you turn on your exhaust fan and you just leave it and you go. So the exhaust fan keeps running and running, and there's actually a wastage of electricity over there. Okay. So second thing is we actually have excessive heat in our surroundings. And third problem is we are unable to know the reading of our surroundings temperature. So this is very important in case if we have any sort of plants or whatsoever that need a suitable temperature for it to live. Alright, so that's why knowing the surroundings temperature is actually very important. Next, the methodology of this project. So firstly, the temperature sensor will detect heat, and then the LCD will show the temperature value. Okay, the temperature value of the surroundings. Okay, let's just say the temperature sensor detects a heat more than 35 degrees Celsius. The fan will turn on. Okay, when the fan turns on, um, when heat goes lower than 35 degrees Celsius, the fan will turn off. Okay, alright, so when the heat is less than 35 degrees Celsius, the temperature sensor will continue to detect heat. So that's how this whole project will work. Okay, so the result that we have done in testing with this project is we have analyzed three different places, which is kitchen, bathroom and bedroom. These are all places in every household. Alright, so in kitchen, as you can see, during the morning the temperature is low. Okay, so when the temperature is low and less than 35 degrees Celsius, exhaust fan is off. Okay, and when it's in the late afternoon from 11 and above, the temperature is 35 degrees 0.5 and the exhaust fan will turn on. Okay, late in the evening, temperature is 37 degrees Celsius and exhaust fan has turned on. Okay, whereas in the evening, late in the evening, the surroundings are cooler and therefore there is no any activity from exhaust fan. Same goes to bathroom and bedroom. During the morning, temperatures are low, and late afternoon, for bathroom there's actually a spike in temperature, so therefore exhaust fan turns on, whereas in bedroom there is no it still remain a cool temperature, so therefore there is no any activity from exhaust fan doesn't turn on. Whereas in the late evening, sorry, both temperatures is above 35 degrees Celsius because of the heat in surroundings. So therefore both times exhaust fan has turned on. Okay, and at night or late sorry, at night late in the evening, temperature has gone down back to less than 35 degrees Celsius, so therefore exhaust fan has remained off. So this is the graph over here to show how different time has different temperatures. Okay, okay, the advantages of this project is firstly it's able to save electricity consumption. Okay, so when you turn it on, it doesn't keep running and running for the whole time. Okay, when the temperature comes down, it will automatically turn it off. Next is it is able to maintain an optimum surroundings temperature. All right, so you don't be in a place where it's too hot, okay, where there is excessive heat in your surroundings. Next is there are warnings in case of spikes in surroundings temperature. All right, so in this project there will be a warning, a visible warning, which is led will light up, and also in lcd there will be a notifier where high temp will be blinking. There's a word high temp and it will continuously blinking. That also acts as a visible warning. Next, applications of this project is, first you have households. In households, definitely we all have exhaust fan in our households. So in why is it important for this project to be in households? Because it can able to be automated for every households. All right, we don't have to control it and it can just run by itself. Next we have is factories. Factories usually, most of the factories deal with high heat objects, especially manufacturing factories. All right, so for them it will be a very useful item. Next we have is agricultural industry. Agricultural industry is actually considered an important industry for this project because they actually deal with a lot of plantations, and certain type of plantation requires certain amount of temperature for it to live healthily. So therefore when they have this automated exhaust fan, they can control their temperature according to however they want. Next is the commercial potential of this particular project. So this product can actually be used in high heat usage industries, just like how I mentioned just now in the application. Those industries which has high heat usage, this product will be very useful for them. So that can be seen as a commercial potential there. Next commercial potential is again for agricultural industries, narrowing down agricultural industries to farming such as cow farming, goat farming, and all any sort of farming. They actually require a specific temperature for their organisms to live healthily. So therefore this automated temperature exhaust fan can actually help them with this required temperature. Next is household. As what I've mentioned earlier, every household also needs to maintain their surroundings temperature. Okay, so all these three is a very important factor in boosting the commercial potential for this particular product. So that's all from me. Thank you very much. Firstly, we'll demonstrate on T1. T1 is known as temperature 1, and in this house model it represents kitchen. Alright, so when T1 surface 35 degrees Celsius, the exhaust fan will activate and also the LED will turn on. Now let's apply some heat to the temperature sensor. Okay, as you can see, the LED is turned off and also the exhaust fan is turned off because the temperature is still below 35 degrees Celsius. Now slowly, since the heat is being applied, temperature 1 is increasing gradually. Now it's 33.7, 34.5, and it keeps increasing. Okay, now it has passed by 35 degrees Celsius, and there's also a warning in the LCD, high temp, and then you can see the LED lights up from T1, and also the exhaust fan has started running. Okay, so when the temperature reduces less than 35 degrees Celsius, the exhaust fan will automatically turn off, and also the LED will turn off together. Yes, now the temperature is less than 35, so everything is turned off. Next, we will look at T2. We will demonstrate T2. Similar functions. When temperature goes more than 35, exhaust fan will turn on and LED will turn on. Now we've applied some heat, and T2 is 31.32.3, gradually increasing as well. Okay, now it has surpassed 35 and there's a warning of high temp from LCD, and also there's LED has light up, and also exhaust fan has started running. And this will also reduce when temperature reduces less than 35, and exhaust fan and LED will turn off automatically. Okay, now the temperature is reducing, so the situation is cooling down. Okay, now it has gone down less than 35 and everything has switched off automatically, which is exhaust fan and also LED. As you can see in T2, LED has turned off. Now let's look at T3. T3 is okay. Let's apply heat first. As you can see, the temperature is 30.9 degrees Celsius, now gradually increasing as we have applied heat. 32.5.9, it's slowly increasing as there's surroundings heat is increasing. Okay, now it has surpassed 35 degrees Celsius. There's a warning there saying high temp. LED turns on, exhaust fan turns on, as you can see there. Now it's 35.6 degrees Celsius. T3 LED has T3 in this house model represents bedroom, whereas T2 represents bathroom and T1 represents kitchen. It's basically a representative of a house model. Now the temperature of T3 has reduced below 35 degrees Celsius, and the exhaust fan and LED has turned off automatically. So that is all about temperature control exhaust fan using Arduino. It is indeed a very useful idea for our society. Hope you all enjoyed this demo. Thank you very much.